Yes, my name is Norbert Schöll. I'm the press spokesperson of Green Dot in Germany, and I've been with Green Dot since 2001. So I'm not a technical expert, but I think I've seen a lot of sorting plants, recycling plants, and of course always handled with issues concerning recyclability and recycled materials and recycled content. And I participated in a workshop you made a few years ago in Cologne on the Merlin project. So I'm looking forward to seeing what has become of the project.
Great, thank you. Maria?
Yes, hello. I'm a food technician and I've been working on different fields of food. But I'm not working now, but I was working for a consumer rights organization for 9 years, and I conducted some project on food contact materials. So I'm quite interested in keeping the the progress of legislation and yeah, everything.
Okay, which country are you from?
Spain.
Spain. Okay, nice. Francisco and Raul, maybe you want to take your turn.
Yes, good morning to everyone. My name is Francisco Sanchez. I'm a project manager here in ITENE, Spain. I'm basically participating in different projects regarding the valorization and recycling of plastics and paper and carbon. I'm a member of the unit of circular economy and packaging here in this company.
Thank you, Frank. Raul?
You're mute, Raul.
Sorry. Hello, everyone. In my case, I'm colleague of Francisco. I'm project manager in the unit of packaging and food safety. And I work in projects related to food contact materials, give support to business in order to consultancy of new regulations and how to apply the regulation of food contact materials. Okay, and my role in this European project was to validate and evaluate the final materials that we obtain in order to be suitable for different food contact applications.
Okay, thank you, everyone. Yes, as to the agenda point, we have the presentation from Frank, who will introduce us about the Merlin project. What is it about? What are its objectives? How it works? And what solutions it has created. So this will be first a presentation from today, and then after that we will hear from Raul regarding the food contaminant and food contact regulations compliance and risk assessment study of the Merlin demonstrators. And we will then discuss the questions from your side. If you have any questions about the risk assessment of the recycled packaging which we produce in the Merlin product, and we will then get your feedback on that, and then we will wrap up and close at the around 12:25. So I think, Frank, I will start my screen and then you can share your screen.
Okay, perfect. Okay, let me share my screen. Just a moment. Okay. Okay. Do you see my screen?
Yes.
Okay, perfect. So thank you very much for this webinar. I want to start with this first presentation regarding the overall of the project, regarding the project Merlin, increasing the quality and rate of multi-layer packaging recycling waste. Just to start, I want to comment that this project was part of a topic that was called improving the sorting, separation, and recycling of composite and multi-layer materials. This proposal was submitted 4 years ago, and the project has a duration of 3 years. The main budget of the project was of 4.9 million, and the consortium of the project was formed by 14 partners from different countries of Europe, as you can see in the image of this slide. And just to add, this project in that case is a RIA, it's a research and innovation action, and we started from a TRL of 3, and the objective was to increase this TRL of the different technologies developed during the project to arrive to a TRL of 5. So this is the main challenge that we have in the project. Regarding the consortium, as I commented, we have 14 partners from 7 countries. As you can see, more of them are from Spain, from Italy, from the Netherlands, and there are another partners from Croatia, Belgium, France, and let me see, and the Netherlands, yes. And the case is all the technical partners are more or less in the same area, in France, Spain, and the Netherlands, in order to avoid the transport of more of this waste that we want to recycle, to valorize during the project, in order to decrease this type of travel of the waste. And regarding the different entities of the project, as you can see in this slide, 6 of them are SME, 4 of them, like for example, ITENE, are RTOs, technological centers. 1 is a non-profit company, and 3 of them are large companies. Basically, there are companies are from the recycling and validation of the laminating material from the project. As a summary of the Merlin project, we want to start commenting what was the origin in order to start with this proposal. The main problem that we have currently also in Europe and internationally, there is the big quantity of post-consumer packaging waste that it's obtained during all of these years. You can see example of the quantity of this post-consumer packaging waste only in Europe, that is more than 18 millions of tons per year. This data is from 2018. That was the data that we have when we were preparing the proposal. From these almost 14 millions of tons, basically only 42% is recycled at this moment, and more or less the 40% is incinerated, and the rest is sent to landfilling. So in order to increase this recycling rate, it's part of the project to develop these technologies in order to be feasible the increasement of this recycling rate. The impact that have the material that is not recycled at this moment is an economic impact of more of 10,000 millions of euros, and an environmental impact of more of 7 millions of tons of CO2. So it's important to increase this recycling rate in order to decrease, of course, the economic and the environmental impact. And in this project, in Merlin, we are focused in basically the 3 main factions that currently are not widely recycled. In that case, there are the rigid multi-layer packaging, basically the trays that you use for example, the meat or for example the fish. Flexible packaging, basically made from PET and different polyolefins like polypropylene and polyethylene, and metallized flexible packaging made with PET, a layer of metallized film, and finally an internal layer of polyolefins in order to avoid the degradation of the material that there are inside of this type of packaging. Why multi-layer packaging? There are 4 main reasons in order to try to recycle and valorize this type of packaging, the multi-layer packaging. First of all, there is a packaging that is widely used due to its high performance in order to have these different barriers in order to not suffer the food any degradation. So 17% of the packaging that there are currently in the market is performed by different layers in its structure. The identification in plant is complex, basically because if the material, the packaging have different layers. In the case of the current technologies, for example, the IR is only feasible to identify the external layer. But if the material is multi-layer, maybe we are analyzing only the external side, but we are missing the rest of information of the different layers. Regarding the different nature of the layers, as I commented, makes recycling difficult. So, of course, in this project, apart from this delamination of the different layers of the packaging, we were developing a process of additivation in order to improve the quality and the properties of the material recovered. And finally, this delamination should be suitable for certain very specific structures. So in that case, in the project, we analyze also the different packaging in the market in order to not only evaluate what are the main polymer layers used in this type of packaging, but of course the analysis of the adhesive in order to be the layer to be attacked in order to delaminate the layers of the different samples that are the focus of the project. The main objective of this project was the development of a new sorting, delamination, and recycling processes in order to valorize and recycle both the flexible and the rigid multi-layer post-consumer packaging, and in order to produce a new packaging solution in order to obtain this demonstrator that are the main objective of this webinar, in order to evaluate what is the food contact analysis of the demonstrator obtained with these delaminated and recycled layers. And you can see in this slide also the different tasks that were developed in the project. In gray, you can say the first of the steps in this project, basically the sorting and the packaging identification using hyperspectral imaging, combined with photonic techniques in order to identify the type of structure in the sorting line, and in order to identify the different layers of the material. Apart from this, the artificial intelligence in order to develop the robots that take the different samples from the sorting plant, and finally an industrial proof of concept in Presero facilities in Seville, in order to combine these two different techniques, the hyperspectral imaging and the artificial intelligence. Once the material is sorted, once we have the trays, the flexible packaging and the metallized flexible packaging, we can start with the delamination and the separation and recovery of the different materials. There are basically three main techniques in order to develop this delamination. In the first of them is the selective depolymerization of the PET from rigid multi-layer. This technique was developed by Ionica in the Netherlands, and basically the objective was to depolymerize the PET from these rigid multi-layer trays and recover the monomer of the PET. In that case, the monomer that was obtained was BHAT with a high purity. regarding the flexible packaging, the non-metallized flexible packaging, that was a task that was developed by ITENE, and we work in the delamination of this type of structures, comparing traditional and green solvent. And in that case, the main green solvent that was used in this project was the supercritical CO2 with a high temperature and pressure conditions in order to separate the main layers of this type of packaging that are formed basically from PET and PE. And in that case, we use in the supercritical CO2 plant also different co-solvents in order to increase this percentage or this efficiency of delamination. Finally, the solvent-based delamination for metallized flexible packaging was a task that was developed by the University of Bologna in Italy. And basically, they are experts in delaminate this type of material and obtain basically the PET, the PE, and the aluminum layer in a different ways, different flows. The next step is the recycling and the recovery and reprocessing of the material in order to repolymerize and producing a new pellet of this type of delaminated material. There are three basic technologies: the repolymerization from the PET obtaining from the rigid multilayer in order to obtain this final PET. They are using the monomers obtained in the previous step in order to produce the PET, and this repolymerization was obtained in Indorama facilities in the Netherlands. And there are two different processing, again, that there are the recovery of the delaminated polyolefin from the rigid packaging application and the recovery of the laminated PET and PE from flexible packaging application that were performed by FEA in France. In these two tasks, basically the main objective was to additive this type of material and increase the quality of the material, to compatibilize these different flows and have the final pellets of PET and PE in order to be sent to the final part of the project, that is the validation of the upcycled packaging. In that case, we obtain 4 different demonstrators in order to close the loop of the valorization. In that case, in another slide, I will comment in detail all of these 4 demonstrators. And apart from this, the safety assessment that will be the result that Raul will share with us in this webinar, and the circularity demonstration for the upcycling material developed. This is in that case, in this slide, you can see the detail of the different tasks in the project. Just to start with the multilayer packaging waste, as I commented in the previous slide, we can identify and sort this material, and there are these 3 basically technical lines in order to separate the different layers of the material, the rigid multilayer, the non-metallized rigid multilayer, with this catalytic depolymerization and the depolymerization with supercritical fluids. Regarding the flexible multilayer non-metallized supercritical fluids also, and this evaluation of the green versus traditional solvent, and regarding the flexible multilayer metallized using this solvent-based separation. And when we obtain these different samples, we can, of course, obtain this PET repolymerization and the obtention of the different PE, PP, and PET flakes in order to be sent to the final final step, that is the obtention of the demonstration. As you can see, there are different transversal tasks also in the project that, of course, there are very important. That there are the food contact safety analysis, the circular by design, the recycling cycle analysis, and the knowledge generation, and finally the life cycle analysis and the human safety analysis. All of them, there are transversal tasks, but improve the quality of the material, and there are a support in order to have a final conclusions of the project. Regarding the main pillars that they are developed in the project, just to comment that there are to expand the emerging smart waste management sector in order to introduce different smart technology in sorting plant, as I commented, using this hyperspectral image and the use of robotic in the sorting plant, the delamination of the different multi-layer structures, rigid, flexible, and the metallized flexible multi-layer, improve the properties of the recovered material, in that case the PET and the PE, using this additivation in order to improve the quality of the material and produce this final packaging prototype in order to check if the final prototype obtained with the material recovered during the project have the same quality than the material that was the origin of the project. And as a main pillar of the project is the develop and promote this new sorting, delamination, recycling, and validation processes in order to obtain this final demonstrator that permit to have this closing the circular economy loop of the project. There are the different demonstrators that we have obtained in the project. As you know, there are 4. The first of them is the pod of LDPE. In order to obtain this pod, we use this upcycled polyolefin for rigid packaging. In that case, this polyolefin was basically the polyethylene and was injected in the ITC facilities. ITC is a company, a manufacturing company that is located in the community, in Valencian community in Spain, and they perform this pot of LDP material recovered, as I commented, during the project, and also in ITC was obtained the bottle of PET. This PET, the origin was the rigid trays. These rigid trays, as I commented previously, were depolymerized in order to obtain the BHIT. This BHIT was repolymerized in order to obtain this PET, and this PET was implemented in the injection blow molding machine in order to obtain this demonstrator that is the bottle of PET. And there are another two demonstrators more that there are the PET monolayer tray. In that case, we use the repolymerized PET from rigid packaging. In order to obtain this monolayer tray, there are needed 2 different steps: the gas extraction in order to obtain the sheet of the PET, and finally the thermoforming in order to obtain the tray using this sheet. Both processes, the gas extraction and the thermoforming, were performed in ITENE facilities. And just to finish, the last of the demonstrators that were obtained in the project is the multi-layer film, the PET and PE multi-layer film. For this obtention of this multi-layer film, we use different polyolefins and PET material delaminated from flexible packaging, both flexible, non-metallized flexible packaging and metallized flexible packaging, in order to laminate this material in ITENE facilities. ITENE is a company that is located in Italy, and they are producer of this type of film. And finally, we obtain this multi-layer film of this using this recovered material. And just to finish, I want to share with you the social media of Merlin project. If you want to have more information of the project, you have in this slide the Merlin project website, the mail. If you have any comment or any question, you can share with with us using this email, and basically the different social media from LinkedIn and Twitter that basically we share with all the people of the world the different news, the different development that we are achieving during this project. And this is the different partners involved in the project, and that's all from my side. I don't know if you have any question.
Thank you, Frank.
Thank you.
For the nice presentation of the Merlin project. Yes, so is there any question from your side, Norbert or Maria, to Frank?
Yes, I would have a few questions. So these, looking into the future, would these different processes be realized in one plant, or would there be different plants for each of these processes?
Well, in the case of the delamination processes, the different delamination processes were performed in the facilities of different partners. As I commented,
Yeah.
the delamination of the multi-layer film was in ITENE. The polymerization of the PET was in Jonica in the Netherlands, and the recovery of the material, the samples of the metallized film was implemented in Italy, in the University of Bologna. Yes.
Mm-hmm. Yeah, but well, I'm not a technical expert, but I would look into the markets. So how could we get this technology into the market? And that then you would have to have an upscaling of these processes to certain amounts of material to be also economically feasible. So would you think that these materials, after the sorting, would be transported to one certain plant, there be divided into the 3 different fractions and then processed in that plant? Or would there have to be a sorting into the different fractions before the processing to bring the different materials into certain plants, into different plants for each process?
Yeah. Well, in that case, the innovation of the project in that case started with the performing of different technologies in the sorting plant in order to, as I commented, the implementation of this proof of concept in Presero facilities in order to evaluate if feasible to implement this hyperspectral image analysis and the different robots in civil facilities. It's true that in that case, we perform only a proof of concept with some kilograms of material. The results were pretty good. So our motivation is to implement in the future this process in all the, of course, in a sorting plant in order to delaminate, in order to separate these different material. But it's true that in that case, this project have a TRL a bit low. The objective was to arrive to this TRL 5. So the objective will be in the future to probably have another project in order to arrive to a TRL bigger, in order to implement this technology not only in a proof of concept, but in an industrial, environmental, and have this proof with more material. So there are very I don't know how to explain, but there are very innovative technologies. It's difficult in this moment to arrive to the market and implement all these technologies in a general sector. But maybe in 5-6 years, I don't know, these technologies will be implemented in the real environment, and can be feasible to obtain these different flows in individual flows. Basically the main challenge or the main barrier is to implement these sorting technologies in a real environment. Yes.
Yeah. So looking at an example, so this summer we opened up a new sorting plant for lightweight packaging in Austria.
Mhm.
Maybe you have heard of it. It's called Triplast. And it's sorting 100,000 tons of lightweight packaging coming from Austria and Germany. And they are now producing 24 different fractions of sorted material. And that would mean in future, if we implement the sorting technology you have been working on, that would mean that in future they would produce 27 fractions instead of 24. And these 3 additional fractions would go into the different delamination processes at other plants. So what do you think, how big would the amount of the material have to be to make these processes working also on an industrial scale?
Well, it's difficult
That's too early. That's too early to ask that.
It's difficult to answer to this question. So maybe we need to wait a few years more in order to have a more competitive and more complex technologies in order to compare or to analyze if this process can be implemented in another country, because there is the challenge also that there is not the same sorting plant in Spain, in France, and Austria, because there are different type of containers in the different countries. So it's difficult to have use the same technologies in a country and adapt these technologies in another country. So the main challenge is that in Europe there is currently we are not using the different sorting processes, and we are not using the same containers in Europe. So it's the main difficulty in order to
But this could change in the future, looking at the packaging waste regulation, which forces the member states to reach certain recycling targets. And that means that also the infrastructures have to be amended. So more or less, in a few years, they could reach a similar status, more or less, in all of the member states.
I think it's difficult because there are another, for example, politician interest in order to have these different technologies and the different management of the waste in the different countries in Europe. It's difficult to have a common plan for all the members of the European Union.
Currently, I would I would agree. Yes. Okay. Thank you.
Thank you to you.
Okay, thank you, Norbert. And is there any other question from your side, Maria?
I have a question. I guess that you have to send this project to EFSA for its evaluation.
Maybe this is a question for Raúl.
Yes.
Okay,
I will talk. I will talk in my presentation, but
okay.
it's in the first stage of the development of the processes and the materials, but it's not yet evaluated by EFSA, such novel technologies in the recycle context of the regulation.
Yeah.
Okay, but I will talk in my presentation.
Okay, thank you.
Okay, in case of if there are no any other questions, then I think Raul, the floor is yours. So we are excited to hear about the risk assessment of the Merlin demonstrators on the food contact regulations. Please go ahead.
I will share my screen. Okay. 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 Can you see my screen?
Yes, we do.
Okay, perfect.
Maybe you want to make it bigger?
I put it in the presentation way. I don't know if
we see it not in a presentation mode, but in a present slides. Yeah, no, I think.
No. Sorry, I will. I will. Okay, then. Okay, now you can see it bigger or?
No, it's the same, but I think it's not a problem. You may continue.
Yes. Sorry. In my computer, I see it in the presentation mode. I will try to explain me well. Hello, everyone. I'm Raul Diaz, and I take the floor in order to talk about the risk assessment and the risk of the contaminant migration associated to the Merlin developments. Okay. The contents that I will cover are summarized in this slide. Okay, I will start with a little introduction related to food contact materials and related to the interactions between.
Sorry, Raul. We only see the first slide.
Yeah. Oh, I don't know what could happen.
Yeah, now we are on the next slide.
Yes. Okay. And if I pass, you can see.
No,
You can no.
no.
Oh.
Maybe I share my screen and then.
Okay.
So then
Maybe
you
could be better. Sorry
yeah,
for the.
you stop your screen and then let me share.
Okay.
Okay. So here you are, and you are here, right?
Okay. Yeah. Thank you, Ahmed. Yes, I will start with a brief introduction related to food contact materials and interactions between materials and food into contact. Make a special emphasis in the recycle materials and the risk of the presence of different contaminations. Then I will talk about the different tools that we have in order to ensure the safety and the compliance of the different materials. And I will talk about the European legislation regarding to food contact materials. Okay, I will give a general approach, and I will focus on the main regulations related to plastics and recycled plastics, summarizing the principal requirements of its regulations that are taken into account in order to evaluate the suitability of the Merlin demonstrators. Okay. Then I will talk of the evaluation that we perform of these four demonstrators in order to establish the compliance with the legislator, and talking about the methodology, the main results, and the final risk assessment that we perform. And finally, I will give bullet points related to the final conclusions of the suitable applications that we see for the different demonstrators that Merlin's project provide to us. And then we will open the session of questions and answers in order if you have any question, any comment related to this evaluation, sorry, or the project in general. Next slide, please. I will start with the basic concepts related to food contact materials. Next slide. We need to take into account that food comes into contact with different materials during their life, okay, during the production steps, processing, storage, preparation, and final consumption by the consumer, okay? These materials are called food contact materials. It's important to have into account that are not inert materials, okay? There are interactions between the packaging materials and the food in contact, okay? These interactions are classified in three different ways. We found the permeation, That is the interaction between food and the environment through the material. Okay, for example, could happens that gases such as oxygen pass to the food product from the environment and can cause the density of fatties if the product is a fatty product, or maybe stimulate the growth of different microorganisms. Okay, that this could be a quality loss or a safety problem in that way. Okay. Another phenomenon that we found is desertion, is the retention of substances from the packaging present in the product. Okay, for example, when we have a transparent recipe and we put tomato sauce or other food with a color, maybe we consume the product and the recipe stays red. Okay, this is an example of absorption of substances that give this color to the food. And finally, and the most important chemical phenomenon, and the phenomenon that the legislation is focused to control, is the migration. Vale, is the mass transferation related to the packaging material to the food product. Okay, next slide, please. The migration, as I said, is the transferation of substances that could be present in the packaging material to food. And we can find that the material could be composed by monomers or can be free residual monomers, additives that we use for produce the material, or maybe we can found impurities, degradation products, contaminants, or other kind of substances that we are not adding by intentional way. Okay, this is important in the case of recycled materials. Okay, because it is necessary to take into account that the start point of recycled materials is a container in which combines food packaging, not food packaging as cleaning products, cosmetic products, and any kind of contaminants that can consist with materials that finally will be a food contact material. Okay, for this reason, the contamination process needs to be enough in order to eliminate this kind of contaminants, in order to don't be a risk for the safety of the consumer. Okay, the migration could be by different ways. Okay, could be by direct contact of the material with the food. Okay, could be by indirect contact. Maybe we have a multi-layer material and substances present in the surface layers can migrate to food through the other layers. Okay, and other way of migration could be by set off. Okay, here we talk about reels, for example, where are storage and the non-food contact surface is in contact with the food contact layer. Maybe substances present in this layer could pass to the food contact layer. Is an example is, for example, the printing inks. Maybe substances present in the printing inks could pass to the food contact layer in this way of storage. Okay, for this, it's important to take into account. Next slide, please. There are different factors that could influence in the migration of the substances present in the materials. Okay, one of that is the location of the substance. Is not the mobility of the substance will not be the same if the substance is located in the food contact surface, that if it's in the matrix of the material or is in the surface of not food contact application. Okay. Other important factor is the nature of the substance present in the material, the chemical structure, the mobility of these substances, the molecular weight, the size, the polarity, and the interactions between food, okay, and the nature of the food product. maybe the physical state of the food. The migration will not be the same for dry foods that liquid foods, for example. The pH of the food, the surface area, the contact, the time, the temperature, etc. The next factor is the concentration of the migrants. It is a gradient of migration. Maybe if we have a huge concentration of a substance, the migration probably will be huge. The conditions of contact, okay, the time of contact with the material and food, the temperature. With high temperatures, we will find more migration that in low temperatures, in congelation, in frozen temperatures, in refrigeration, etc. And finally, intrinsic properties of the materials as the thickness, the structure, mechanical factors, etc. Okay, these are the main factors that are involved in the interaction between the substances present in the material and in food. Okay, next slide, please. Said that, I will start to talk about the European legislation that sends the framework on the rules in order to ensure the suitability of the food contact materials to be into contact with food. Okay, and next slide. In this slide, I summarize all the regulation that we have nowadays at European level in order to provide this compliance, this suitability for food contact applications. Okay, on the top of this scheme, we found two regulations. Okay, the regulations 1935, that is the framework regulation. Okay, and sends the framework requirements for all kinds of materials to be into contact with food. Below them, we found the regulation 2023. This regulation sets the requirements regarding good manufacture practices for manufacture food contact materials. Okay. Below these two regulations, we found materials that nowadays has specific and harmonized measures and harmonized regulations at European level. We found plastics and recycled plastics in that context, ceramics, active and intelligent materials, etc. Okay, for plastics, we have the regulation 10/2011. Okay, it's the most studied regulation and set the rules for the conditions of the migration test. And then we found the regulations 16/16/2022 that set the specific measures for recycled plastics. We will talk with more detail of these regulations. And below these materials with specific measures, we found another materials that nowadays don't have these specific regulations. But not having this harmonized legislation does not exempt for the compliance with the framework regulation. Okay, for this we need to follow national legislations, different industrial guidelines that provides to us the enough safety in order to be in compliance with the framework regulation. An example of these kinds of materials are paper and board, printing inks, adhesives, etc. Okay, next slide, please. I will start to talk to the different legislation that applies directly to the four demonstrators obtained in the Merlin's project. Okay, the first one is the framework regulation, the regulation 1935-204. Okay, that states the principle of food safety. This is the most important of this regulation, and all the materials needs to be in compliance and needs to demonstrate the compliance with this food principle. Okay, it states that all the materials and articles, okay, should be manufactured with good manufacture practices in order that under the normal or foreseeable condition of use, they don't transfer their constituents to food in quantities that could endanger human health, bring about an unacceptable change in the composition of the food, and bring about a deterioration on the organoleptic properties of the food. Okay, This must to be demonstrated in order to guarantee the food safety of the material. Okay. Another general requirements that we found in this regulation are labeling requirements, okay, of food contact materials. We can see the cup of the fork, okay, in the slide. Traceability requirements and requirements related to the declaration of compliance. Okay, it's the document that guarantees that the materials is in compliance with the legislation and is suitable for food contact applications. Next slide, please. Then the next legislation applicable to Merlin demonstrators is the regulation 2023 related to good manufacture practices. Okay, it's mandatory that all the food contact materials are produced under these good manufacture practices in order to prevent and control that the production of these materials don't cause harm to the consumer, and the material complies with this food safety principle. Okay, the three main points of the regulation is to have a quality assurance system in order to have enough warranty of the adequacy of the personnel, the installations, the raw materials, in order to fabricate these food contact materials. Another important point is have a quality control system in order to control the assurance system, and have the documentation of both of the quality control system and the quality assurance system. Okay, for in order to apply this regulation, you can use different certificate systems, as the BRC Global Standard for packaging, or IFES PackSecure, sorry. But it's not mandatory that you certificate your system with these standards, okay? But it states a good framework in order to have your quality assurance system. Then in the annex of the regulation, we found specific requirements for printing inks, ¿vale? These printing inks could not be in direct contact with food. And in the part B, we see the different documents that are mandatory to be in the quality assurance system of recycle procedures. Okay, for this reason, in this part is mandatory for the different processes that the recycle processes that Merlin used for obtaining the final demonstrators. Next slide, please. Okay, then I will talk about the specific legislations to the final materials obtained. I will talk about the plastic regulation, the 10/2011, and the recycled plastic regulation. Okay, to set out the principal requirements. Next slide, please. In the I don't see it in good quality. Okay, but I will summarize fast. In the right of the slide are summarized the principal requirements, the three principal requirements of the plastic regulation. Okay, the first one is the compositional requirements. Okay, for a manufacturer to produce plastic, it's important to have the composition is you need that you can use any kind of substance that you want. You need to follow the positive list that is set in this regulation. Okay, I will talk in more detail in the next slide. Then the second requirement is the evaluation of the food safety of the material. Okay, it's mandatory to perform different migration tests in order to evaluate this phenomenon of the transferation of the substances from the material to food. And the last requirement is the documentary requirements related to the declaration of compliance. Okay, next slide, please. Related to the compositional requirements, we have in the Annex 1 of this regulation, we have a positive list of substances that you can use in order to produce the plastic material for contact food. Okay, in this list, we can find monomers and other starting substances, additives, excluding colorants and dissolvents, polymer processing aids, and nanoform substances that are especially authorized in order to have a better idea of the safety of these substances, and that the size of the substance will not affect to the safety of the product. Okay. This is mandatory, but we can use substances that are not authorized following national legislations in the European countries, such colorants, height of polymerizations, or maybe we can use substances that are mixtures of substances that are authorized, or maybe salts of substances that are authorized too. Okay, this is a resume of this part. Next slide, please. Related to the food contact requirements, as I said, it's mandatory to perform a different migration test. Okay, we found the overall migration. Okay, the overall migration is the tendency of the material to transfer the total of the substances, the non-volatile substances that it has. Okay, the regulation sets a limit of 10 milligrams per square decimeter. Okay, and we need to validate if this migration is below this limit. Then other requirement is the specific migration. Okay, maybe in the composition requirements you are using substances that has restrictions about their own migration. Okay, you need to validate that in your use you are not over this migration limit. Okay. Then we can have restrictions about maximum residual content. Okay, here we are not talking about migration. We are talking about the maximum quantity of a substance used in a material. Okay, this restriction is important to have it into account. And finally, we have general restrictions. Okay, general restrictions related to the specific migration of some contaminants that we know that could be present in the final material. Okay, these contaminants are set in the Annex 2 of the regulation and are related to metals and primary aromatic aminas. Okay, the regulation sets different specific migration limit for different metals, and the same for primary aromatic aminas. Okay, we have, in the case of the primary aromatic aminas, we have two specific migration limits. One of 0.002 milligrams per kilo of primary aromatic aminas that are classified in REACH regulation as cancerogen. Okay, then individually we need to measure the migration of these substances. And then we have a specific migration limit related to the sum of the migration of all the primary aromatic aminos that could be present in the material. Okay, this limit is the 0.01 milligrams per kilo, or not detected. Okay, next slide, please. And finally, related to the plastic regulation, the requirements regarding to the declaration of compliance. Okay, so as I said, this is the main document in order to guarantee the suitability of the material for being to contact with food. Okay, this the documentation could be accompanied by supporting documents as test report or other quality documents that support that the material is okay for being to contact with food. Next slide, please. Then I will talk about the legislation related to recycled plastics. Okay, the regulation 1616/2022. Next slide, please. The main important points of these regulations are the ones that I put in this slide. Okay, this regulation applies to all the decontamination processes. Okay, and this regulation classified the recycled technologies in two big families. The first one are suitable technologies. Are technologies that nowadays we have scientific evidence that are enough in order to obtain a material that is safe for being in food contact applications. Okay, nowadays in this family we found two technologies: the mechanical recycle of post-consumer PET, okay, and the recycle in closed loops for all kind of plastics. Okay, in these technologies we have enough enough evidence of obtain food contact materials adequate for their application. But we have another family that is related to novel technologies. Are technologies for once we don't have this scientific evidence, okay? Because EFSA did not evaluate these technologies and are not this basis for establish the safety of these ones. These novel technologies are those are not the mechanical recycle of PET and the closed loops recycling in closed loops. Okay, and this regulation established the framework in order to produce food contact materials with these novel technologies and earn the enough scientific evidence in order to pass as from novel technology to suitable technology. I will talk about it. Moreover, this regulation established requirements not only for the technology, established requirements taking into account the whole distribution chain, in particular with waste managers, taking into account the collection, the sorting, and the treatment of the plastic materials to recycle. Requirements to the recycles for the focusing the contamination process, the traceability, and the labeling of the materials, and requirements for the final transformers of the recycled material. Okay. In addition, we have requirements of register of the union register that is created in order to have the traceability of the different processes, the different recycled processes, and the different facilities of recycle. Okay, this is an administrative act. And finally, we have requirements regarding to the declaration of compliance of the recycled materials and the materials transformed from these recycled materials, traceability and labeling of these materials. Next slide, please. In this slide, I summarize the both suitable technologies that we have nowadays. The post-consumer mechanical PET recycle, okay, that is suitable, but it's mandatory to authorize each individual process in order to have enough warranty that the decontamination process is enough to obtain an homogeneous and safety materials for being to contact with food. Okay, and then we have the closed loop that we talk in this closed loop that it is not at the contamination process, is more than an hygienic condition of the materials, and we talk about close when we have different companies and use the same packaging, okay, and pass from two different companies in this closed loop, and always maintain the traceability of the packaging. Okay, aquí there is no possibility of contamination of the materials. Next slide, please. And then the family of the technologies with the Merlin project development will be is in the novel technologies. Okay, it's important, as I comment then to Maria, that for these technologies be into the market, it's important that has this enough warranty that the processes, the contamination processes, the final articles obtained are suitable for be into contact with food. Okay, for these regulations sends the specifications to produce this material and to sell this material and to earn this scientific evidence. Okay. For this, 6 months prior to start to produce and sell the material obtained by a novel technology, the recycle need to notify to the European Commission of the installation of the new technology and apport evidence and scientific test in order to guarantee the safety of the material that it's produced. Okay, and guarantee the compliance with the Article 3 of the Regulation 1935. Okay, this food contact principle. Okay, if the notifier has the okay from the European Commission, okay, it can produce and sell the material, but batch by batch, they need to publish online data of the safety of the material every 6 months, okay, in order to have this data of the homogenic results of the migration of the different substances that could be present in the material, okay. Over 2 years, maybe the EFSA can assess that the technology is safe. Okay, we have enough evidence in order to establish that the technology is safe and could pass to be suitable. Okay, this will be applied to the technologies that are produced in the Merlin's project. Next slide, please. And then I will talk about the evaluation that we perform in the 4 demonstrators from the Merlin project. Next slide, please. As my colleague Fran says, we obtained 4 different demonstrators from the recycled materials. The demonstrator number 1 was a multi-layer flexible film. The number 2 was a PET monolayer tray. Number 3, the PET bottle, the PET bottle, sorry. And demonstrator number 4 was the LDPE pot. Okay. The validated use, the first validated use for this demonstrator was contact with all kinds of foods, okay, and in conditions of prolonged storage at room temperature or below, okay, in order to cover the contact with the majority of foods that you can buy in the supermarket, okay. Next slide, please. What did the assessment consist of? It consists in apply the European legislation that I told, okay? For this, we perform different migration tests. We perform the overall migration of the 4 demonstrators, the specific migration of the general restrictions present on the plastic regulations related to metals and primary aromatic amines. And then we perform the evaluation of the non-intentionally added substances that could migrate from the different demonstrators, okay, in order to assess the risk assessment of the migration of every substance that could present in the materials, okay. This migration test is based in use different food simulants, okay, that imitate the interaction between real food with the materials, and with accelerate test using time and temperature conditions established in the regulation 10/2011. Okay, next slide, please. For the overall migration, okay, or the measurement of the inertia of the material for transfer the constituents to food or food simulants, and verify that is compliant with the overall migration limit of 10 milligrams per square decimeter. We use the conditions of contact of 10 days at 40 degrees, okay, in order to cover room storage contact and prolonged contact. And to cover the contact with all kinds of foods, the regulation says that it's important to do the migration test with 3 different food simulants. The simulant A, that is ethanol 10%. Simulant B is acetic acid 3%. And D2, that is olive oil, okay, but it's possible to use substitutives to this olive oil, okay, that are ethanol 95% and isoctane, okay, in order to cover the contact with fatty foods, okay. With these 3 food simulants, we cover the contact with all kinds of foods. The exposure was different, okay, with the different demonstrators. For the flexible field, the demonstrator number 1, we form bags in order to perform it by filling the different bags. For demonstrator number 2, we could different specimens, and we perform it by immersion, okay? Because when we perform the trace, we see a defect in the process, and we see that the simulant was leakage a little. For this, we perform the test by that way. And for the bottle and for the pot, we perform the migration test by filling this packaging. Okay, next slide, please. For the study of the specific migration of metals and primary aromatic aminas, first of all, says that the specific migration is a maximum limit set for each substance, and it's set on the basis of toxicological studies performed for each substance. Okay. For this, the conditions to cover the same conditions of the overall migration, the regulation says that the specific migration needs to be performed at 10 days in 60 degrees. Okay, and we use the most restrictive food simulant for this kind of substances. Okay, for metals and for primary aromatic aminas, the most restrictive is the acidic food simulant. Okay, the simulant B is acetic acid, 3%. And then we put these food simulants in contact with the material in order to obtain the migrator mix. Okay, and then with this food simulant, we use a different chromatographic techniques in order to establish the limit of the specific migration limit of each substance. Next slide, please. Okay. For the NIAS evaluation or the screening of impurities, degradation products, reaction products that could be present in the final materials, we evaluate different fractions, the volatile fraction, the semi-volatile, and the no-volatile fraction. And for this, we need to use different chromatographical equipment, okay? We need to use gas chromatographs with different detectors and liquid chromatographs with high resolution detectors in order to identify and quantify the substances that could migrate from the materials, okay? The conditions for volatile substance, we perform a thermal desorption from the material itself, okay? And we extract the headspace substances with an absorption fiber, okay? And then we use this fiber, we inject this fiber directly in the gas chromatographs. And for the semi-volatile and no volatile fractions, we perform a migration, 10 days at 60 degrees, with the most restrictive simulant for each material. For PET is ethanol 95%, and for polyolefins is octane. Okay, and we inject directly these simulants in the different chromatograph equipment in order to obtain the screening of substances. Next slide, please. Regarding to the results that we obtain, we see that for simulant A and simulant B in overall migration, we see that all the materials are okay, are below the limit of 10 milligrams per square decimeter. Okay, for this reason, for aqueous and acidic food products, the materials will be okay. But for the fatty food simulants, we see in demonstrator 1, 3, and 4 that for one of the substitutives, the result is not okay. Okay, we see more migration than 10 milligrams per square decimeter. Okay, for this reason, in taking into account the methodology, the demonstrator number 1, 3, and 4 will not be suitable for being to contact with fatty foods. Okay, but will be suitable for being to contact with aqueous, acidic, for dry foods without fatty in their surface, etc. Next slide, please. In the case of the specific migration results for metals, all the materials are below the specific migration limit established for the 24 substances present in the Annex 2 of the Regulation 10 2011. For this reason, no safety concern in this migration. Next slide, please. But in terms of the primary aromatic aminas, as I said, we found 2 restrictions. The specific migration for the cancerogenic ones that are the listed in the REACH regulation, and the specific migration for the total sum of primary aromatic aminas. Okay. In that way, we see that in demonstrator 1, One primary aromatic amino classified as cancerogenic is migrating in a huge way. Okay, for this reason, this specific demonstration will not be suitable for food contact application. Okay, we see that the substance that is migrating is an intermediate of making polyurethanes. Okay, for this reason, we recommend apply the good manufacture practices in order to select the additives to use in the manufacture of this demonstrator. The substances that are used for the machinery, lubricants, greases, etc., because could be a contaminant of the process, or maybe could be a contaminant from the recycle process, and the decontamination process is not enough in order to eliminate this substance. Okay, this is the only point that we see in the safety of the demonstrators in the specific migration test. And then next slide, please. I will talk about the NIAS result. And for this, we obtain a screening of different substances that migrates from the different materials. Okay, we see from
Rahul,
the PET.
Rahul, just try to be quick. We just need to. We also should give some time for question and answers.
Yes, sorry. I will be fast in the last conclusions. For perform the risk assessment, first, we follow the approach of Plastic Europe, and we, knowing the substances that migrate from the different demonstrator, we search for these substances in the positive list of food contact materials, the Annex 1 of the regulation of plastics, the Swiss ordinance, or other positive list that applies in the European countries. Then we follow the chemical classification in order to establish if the substances are CMR, cancerogen, mutagenic, or toxical for reproduction, of very high concern, or if they have endocrine disruptor properties. Okay. Then we search for available individual toxicological information. Okay, in order to establish a specific migration limit, taking into account different parameters of toxicological concern. And finally, if we don't find information related these points, we use the TOX3 software that gives to us information related to the toxicity of the substances according to the chemical structure of that, okay, according to the reactivity of the substances. And we can classify the substances in 3 different groups according to the peligrosity, or to the risk of the substances. And we can estimate a specific migration limit for each class of danger. Okay, next slide, please. The conclusions that we obtain for the risk assessment is for demonstrator number 1, we see 19 substances migrating, but none of them was CMR or of very high concern related to this primary aromatic amino that we see in the specific migration. Okay. 9 of these substances were authorized and were below their specific migration limit. And for the non-authorized ones, we see that with the TTC approach are under their specific migration limit. Okay, for this, in terms of impurities and non-intentionally added substances, will be fine, this demonstration, and with no safety implications. For demonstrators number 2 and number 3, the material was the same. For this, we work in the own material in order to see which substances could migrate. Okay, we found 11 substances. Okay, inside these 11 substances, we found 1 CMR substance, but this substance was authorized and was listed in the plastic regulation. Okay, and we found that the restrictions of contact of this substance are compliant in the plastic regulation. For this, no hazards are no implication of safety are provided to the consumer. The rest of the substances, we found that 8 of the 11 substances were listed, were authorized, and we were below this specific migration limit. And for the three ones, we see that we are under this TOX3 specific migration limit. For this, no safety implications will be for the consumer. Okay. And finally, in the 4th demonstrator, next slide, please. We found a total of 20 substances none of them were CMR of very high concern with properties of endocrine disrupting. And 14 of these substances were authorized and listed in positive list. Okay, for this, no implication of the presence of these substances for the safety has found. Okay, for the rest of the substances, the non-authorized ones were below the area-specific migration limit, taking into account the risk assessment is established by the structure, by the chemical structure of the substances. And for the non-volatile substances that we found, but we not quantify, we found that there are not CMR, there are not of potential hazard for the consumer, taking into account the intensity of the peaks and the concentration of these substances. Okay, for this reason, we can establish that in terms of impurities and non-intended added substances, the materials will be adequate in order to be into contact with food. Okay. And finally, next slide, please. The final conclusions that we obtain of this validator for food contact applications are that the European legislation is mandatory for food contact materials and is the tool that we have in order to ensure that the materials are suitable and safe for being into contact with food. Okay, it's important to have into account that requirements regarding Regulation 1616/2022 related to recycled plastics for food contact materials are not only focused on the final material, are focused too in the processes, the contamination processes, and has requirements for all the actors of the chain, okay, of the recycled plastic. For this reason, it's important that these requirements will be compliant, and in the future to submit the different technologies as novel technology in order that EFSA and the European Commission take the decisions to put it as suitable technologies. Okay. Regarding to the demonstrators, we found that demonstrator number 1 nowadays will not be suitable for food contact applications, but applying good manufacture practices and controlling the presence of primary aromatic amines maybe in the future could be a development for food contact applications. For demonstrator number 2, for the PET tray, we found that it's suitable for contact with all kinds of foods. Okay, fresh meat, fresh fish, all kinds of foods, and storage of room temperature or below, and prolonged storage. Okay. And for demonstrator number 3 and number 4, the PET bottle and the LDPE pot, we found that is suitable for contact with all kinds of food except fatty foods. Okay, for this reason, they could be into contact with drinks, with cereals, with sweets with no fat in the surface, with fruits, vegetables, with different foods that don't contain fatty in their surface. Okay, and that's all from my side. Thank you very much for your attention. I don't know if you have any question that you want to share and to ask.
Thank you, Raul, for the very interesting presentation. And I think we can have a few more minutes and to address any questions Norbert or Maria you may have. Please feel free to ask to Raul.
Maria, ladies first.
I just wanted to ask if you have any special concern when passing the EFSA evaluation. What do you think that it's more difficult to pass, of if you think that there are?
Yeah. I think that the most complex in terms of recycled plastic is to have the homogeneity of the input material after the before the decontamination process. Okay, and that the different batches that you extract from the decontamination process has the same homogeneity. Okay, and how to ensure that your decontamination process will provide this homogeneity. For me, this is the key for obtaining a suitable food contact material. Then the validations are the same for virgin plastic. Okay, maybe have a special focus on the NIAS, on the non-intended use substances, and how to establish the risk assessment and of these substances in order to avoid any kind of risk for migration to the consumer.
Okay, thank you. And I also have a question regarding when you explained the novel technique, the procedure. Between step 2 and 3, the two that it was, if you get the okay from the commission, you can start producing until the third one, that it's you will get the okay to be considered suitable. Can you say, or can you?
Yes, I was a little fast because the procedure is complex. Okay, but firstly, what you need is 6 months after to produce the material. You need to apply to with a technical dossier with the technical information of the process, all the tests that you perform to the safety of the material, to the European Commission in order that they establish if the process is okay and is enough to produce a safety material. Okay, then you can start to produce and sell the material, but you need to provide a test regarding to the migration of substances with a molecular weight below 100 of Daltons, okay, in order to establish if the different batches are homogeneous and are identically in terms of migration. Then you can stay in this phase from 2 to 6 years, if I'm not wrong.
That's what the presentation said.
Yeah, and then the EFSA could state this novel technology as suitable ones. Okay, and then maybe they can put any requirements. Okay, but will be suitable if you follow these requirements for all. Okay, to produce this
And
material.
do you get in English, patente? I mean that once you pass and the commission say okay, is your process? I don't know.
Yeah. I think
is it protected by law?
Yeah, how to protect these processes? I think this is a question maybe for Fran, but I think that maybe we are in the first steps of this project and this development.
Yeah, okay.
Maybe the future, if we have more work and more results and how to demonstrate this homogeneity, maybe it could be interesting to protect these results.
Okay, thank you.
Thank you.
Okay, since I have to join next meeting, I would just have 2 or 3 main remarks. Thank you for the very interesting presentations. I think that there is a big potential for technologies like yours, since we have also to meet in the future recycled content quotas in new packaging. It's a bit since 25% of the collection of lightweight packaging in Germany is film and mainly LDPE film, but there are also contaminants of PP film in there. So it's 20 to 25%, which is a big amount of collected material. So I see a big potential for that. And it's a bit sad that the results for these materials were not first rate, so to say, because they are not suitable for food contact currently by now. And I also see the problem with the homogeneity of the collected material. We see that in our plants where we are processing the material to new recyclates. The idea could be not to aim for food contact, but for other packaging material, which is also wanted very much, because we have to process this material into new packaging in the future. And the second potential I see is PET crates. There's also a big fraction of PET crates in our collection system that is surely not only the case in Germany, but also in other European countries. And there are currently only few recycling processes for these materials, and mainly these crates go into energy recovery. So there's a big potential for that, which I would, and there I would see a big potential for your technology. As would propose to look more into the amounts of material. So there are critical amounts in, I mainly can speak for the German market. There are critical amounts of material you have to reach to implement sorting technologies in the sorting plants and to implement recycling and recovery technologies and processes into the infrastructure. And you have to reach these amounts to make the technology suitable for the market. And I would see that as in one of the next steps in your project to look into the amounts, how much of the material is in the market, how much of the material can you reach with your technology to make it available for recycling processes. And that's a big economic factor, which is very important to get that technology into the market, which certainly will be wanted in the future. So that would be my remarks to that. Thank you again very much for that. I've found this very interesting and I'm very happy to be part of it. And now I have to say goodbye and thank you again. And
thank you, Norbert. Thank you,
Thank you very
and
much.
we will share with you the results,
That
the
would be great.
publication report, and also the presentation from Raul and Frank together, hopefully soon, and we will continue in contact. Thank you for joining.
Thank you.
Very much.
All the best to
Thank
you.
you.
Bye
Thank
bye.
you.
Bye-bye.
Thank
Thank
you
you very
all.
much.
Bye.
Bye.
Bye. Bye.